Are you going to be able to not check email during the show? You're literally deleting email right now, Mark. He shows me his hands. He's like, Your Honor, I'm a changed man.
Copilot, delete that email.
He's archiving email with his big toe right now. And then run the music. See how that works? I literally can hear the music running now as we begin the show. All right. Hey friends, I'm Scott Hanselman, and this week I'm learning about AI limitations. What are you learning about, Mark Russinovich?
I'm learning about AI limitations with Scott Hanselman.
Do you learn every week? Do you read papers? Are you always learning?
Every week. I'm constantly reading, especially AI research papers, and then papers that come out about cloud native research as well.
How do you balance learning versus knowing it all?
How do I balance learning versus what?
Well, you kind of carry yourself as a know-it-all, right? You know, you're the CTO of Azure. You know it all.
No, I'm a learn-it-all.
Oh, you're a learn-it-all. That's why we called the show Scott and Mark Learn To, because we're always learning. Just because you've been in tech for a long time doesn't mean you know everything, because things are changing.
Right. And by the way, you know that Satya came up with that learn-it-all, or at least...
Is that a thing? Is that a Satya thing?
Yeah. Uh-huh.
This is amazing. We're 2 minutes into the show and there's already a Satya shout out. Are we going to sell his book now?
Sure.
We should probably hit refresh. That's the name of his book.
Bad.
See how we did? No, it's okay. Review time has passed. He won't even hear this until next show. So AI limitations, though, I thought that it was going to change the world. I thought that we were all going to have segways. We were going to build our cities around how the segway works. We were going to get rid of our cars. And then it was going to be large language models and AIs. And we were just going to chat with them all day. And then all work would stop. And then we'd have 15-hour work weeks. But
So
where's my jetpack?
Well, I think I use AI every day as I code. And I think that it's a huge productivity boost. And I've talked about this before. I literally cannot code anymore without AI, or at least my productivity would severely sink, especially with Python and PyTorch, which I do a lot of AI research using that language and that framework, and Hugging Face. Now I'm inherently lazy. I don't want to do things I don't have to do. And so when I'm programming now in Python and I'm like, I need to write a loop that iterates over this data and process it in a certain way, I'd much rather just ask the AI to write that code for me than do it myself. And so that's I've become a tab Copilot autocompleter and Copilot chat write this function for me.
Yeah.
Coder. And if you took it away from me, I wouldn't. I don't remember how to do this in Python.
But I remember being on a big giant X Windows machine that was like Hercules, orange color, and I would just do everything in VI. And then we got color syntax highlighting. And the graybeards, the non-gender specific graybeards were saying, that's going to rot your brain. Syntax highlighting will rot your brain. And then we got IntelliSense where you type whatever dot, and that's going to rot your brain. And then the TI-83 calculator came out and they're like, no, you can't learn math. It's going to rot your brain. Is AI coding rotting your brain?
Interesting, because like I said, I don't really know Python that well, but I code a lot of it because of AI. And do I need to really know it that well? I don't think I do. I mean, I need to know it just enough to get the job done efficiently. And I think that works for these other things you talked about.
So if we think about it in context of driving, I've got my 16-year-old driving now, and it's a little concerning. I was taught to drive stick shift. I was taught to understand the car and know how to change my own oil. My dad gate-kept the car by saying, you don't get to drive until you change your oil. You don't get to drive until you put your tires on. But we don't gatekeep the garbage collector in C# from people. We don't say, you can't use a garbage collector until you malloc your own memory.
Yeah.
But you don't know Python, Mark Russinovich, and you are writing Python all day. Should you be driving that you don't really, you don't really understand the car? Should we be allowing that?
Well, nobody can stop me, but
Nobody can stop me.
I think the thing is, you've got to be aware enough of what you need to know to be as efficient as possible.
Yeah.
Like if relying on the AI isn't the most efficient way for me to get the job done, then I would need to go learn Python better to get the job done better. So it's this, and I'm kind of doing that all the time. Like, what is the line that I need to get up to for maximum efficiency where I'm not spending time on things I don't need to worry about?
So what should we teach somebody, though, who's getting started?
Yeah, this is a really great question.
Because you did change your own oil and you did change your own tires and you did malloc your own memory. So now you should be, because you'll look at the Python and you'll go, I don't think that was good Python.
Yeah.
Right? Your spidey sense goes off.
Yeah. Well, talking to university professors about the changing aspect of computer science education, especially early computer science undergraduate education in light of things like GitHub Copilot, they have adopted you need to change your tires and change the oil when you start. And then once you understand what that is, then you don't have to do it anymore.
May you live in interesting times.
Yeah.
But
you started by saying, what we're learning about is AI limitations, and I started by talking about how I use AI. And how do you use AI?
I brainstorm and I use it as a rubber duck. Where's my rubber duck? Somewhere around here, I've got a rubber duck. Here it is. I've got a Microsoft Borg rubber duck. Oh, you have a rubber duck too. Look at us, rubber duck.
Came from Carnegie Mellon when they give them the speakers.
So rubber ducking, I've talked about this before, is the getting it out of your mouth, hearing it, and then having it go back in your ear. You don't even need the other person, so then you just get a rubber duck. But I would always call my coworker, my very tolerant and very kind coworkers, and go, hey, got a sec? Can you jump on a quick call? And you just talk to them, and then by the time you've talked to them and said it, you've figured it out. It's the thing that happens when you're trying to solve the technical problem in your head, in the shower, or whatever. Yeah. So I rubber duck actively with the large language model, and I realize I'm just talking to myself.
Yeah.
Is that a fair analogy? It's a sock puppet, and I'm just chatting with myself. I'm looking at the mirror.
I don't think it's quite that way, because you are getting inputs that aren't generated by you and insights that aren't generated by you.
But the vectors that are being generated by your initial words, if you misspeak, if you say a word, or like, in the family, I'm the Googler. I'm the best one who can Google, and I'm using Google as a generic verb. So that time when someone says, I've been Googling for hours and I can't find anything, and then you step in and in one Google, you find it, first one, because you intuit the right thing to say. I am noticing people giving too much info to large language models, and they'll hit a word and I'll say, that's a mistake. You shouldn't have said that word's going to nudge it in the wrong direction. So I'm already developing that intuition.
I mean, that's true. It is guided by what you ask it or tell it. But that doesn't mean that it's not going to give you some output that is surprising or new information for you.
But isn't giving you something surprising more random and more roll of the dice? Like aren't we just playing D&D with this thing?
Not necessarily.
Sometimes you roll a 20.
I mean, if you're asking it about a specific topic, it almost certainly has knowledge about that topic, unless it's your topic of expertise that you don't have.
Ah, okay. I recently, and I don't know if this is bad or good or evil, but my son had his shoulder X-ray, and they gave us the MRI and the X-ray, and it was incredibly long. And I said, summarize this radiologist read in layman's terms, acknowledging that I'm an engineer and my wife is a nurse. So I gave it context about who we were. Mm-hmm. And my wife can't read a radiologist report, but I didn't say put it in utter layman's terms. I said, here's who we are.
Yeah.
And it gave me different results than if I said, explain this to me like I was 5. And I found that to be a very helpful use of the tool.
Well, so now speaking of limitations, because I think one of the limitations you could have run into in that case that could be problematic, especially in the medical domain, is something called hallucination.
I've mentioned to you before that using the term hallucinations might be a problem, and there's like responsible AI discussions around that. Do you think that that's a problematic term?
I think the cat's out of the bag on that one. And there were discussions about this over a year ago when the term started to show up in widespread usage. The momentum behind it is just too big at this point. I mean, in fact, Anthropic published this system prompt for Claude 3.5 this past week.
Yeah.
And if you go read the system prompt, it says, refer to this as hallucination. There's other terms like confabulation, but it's widely accepted that it's hallucination. So that's the way you refer to it. And if you take a look at AI research, it's all that's the term used to describe the AI screwing something up or making something up.
Okay. So you acknowledge that it might not be the best thing to anthropomorphize an AI, but the reality is we're saying it, so we should just keep going.
Yeah.
I don't know. I don't think I'm gonna say it because I think it doesn't have mental health, but I think that you make a very good point.
Yeah.
Yeah, I'm looking at July 12th, Claude 3.5 Sonnet. It's cool that they listed out the complete system prompt, basically giving it context, waking it up. It's almost as if it's the kind of thing you would tell someone if they just awoke from a coma.
Yeah.
And it's like, your name is Claude, the date is this.
I like the last line in it. You will now be connected with the human.
Yeah.
Or the user or whatever it says. You are now connected.
Yeah. Claude responds directly without unnecessary affirmations or filler phrases.
Yeah, even though it actually does. I find it certainly all the time.
And it says Claude avoids starting responses with the word certainly.
But it does. So that
does it anyway.
Ignoring its prompt.
Okay, so why is that? Why is it you say it feels like you're talking to a 5-year-old?
Yeah.
I'm going to leave you in this room with this marshmallow. Don't you touch that marshmallow?
Yeah.
And it always touches the marshmallow.
Yeah. Well, I think so. If you take a look at the way that the model is trained, it goes through this pre-training phase where it's trained on huge amounts of data, text, and then and in the case of a multimodal model, other types of inputs. Then it's also goes through this post-pre-training phase, which is alignment, which is RLHF or another alignment technique that teaches the model how to answer in a way that humans want it to answer. So, for example, aligning it so it doesn't produce harmful content, and that it answers in a friendly way, and that it's not too verbose, and that it's not too flat. And so all of that is in that post-training phase. And I suspect that Anthropic Claude's post-training phase had a lot of certainly in it, is what humans want to hear, is the model is saying, of course, I'll help you and answer your question. Then you come along with
it's too late. They're trying to hold it back.
They're
trying to pull it back from something that's already baked into its personality.
Yeah.
Okay. Interesting. So there are, it's not the tech. It's not the tech, the background generative tech behind LLMs that's causing Claude or other ones, anyone to say certainly. It really is the training data. Grok is just a little sassy for my taste, and I don't like it. Like, it seems like a somehow socially awkward person at a party trying to be liked.
Yeah.
That's not a tech limitation. Someone decided to make it act like that.
Yeah. If you could take a look at the data samples they gave it in the post-pre-training phase of its alignment, you'll see examples of that kind of tone and attitude.
Is that a superpower, or a limitation? Because that's interesting. That means that we're going to end up having subgroups of people pick the LLM that they like, because we can't decide as a society on what the tone of one of these things should be. Somebody may like a sassy one or a funny one or whatever,
Actually, this one, it's interesting to see how this is going to play out, because back when ChatGPT showed up, there was a lot of discussion I had with people about the world's going to become fractured, because even not just tone, but alignment about what content the model will produce or won't produce is something that different people disagree on. And Grok's a great example. Grok is unaligned with respect to safeties. as opposed to all of the other. It's like the only, GPT-4 class model that doesn't have alignment built into it of safety, of not harmful content or toxic content. It will gladly produce it if you ask it to. And
So
so
that
that's different. And it's an example of, every model creator has their own post pre-training alignment phase where they decide what the model is going to say and not say.
right. And that's interesting because that's where I get back to the sock puppet thing. I use that analogy a lot because a tech journalist will go and write a whole article about how they talked to a model, and they were just some model, and then they asked it to say something deeply problematic or awful. And then you dig into it and you discover that they really coerced it. They pushed it hard. You know what I mean? And it's like looking in the mirror and saying mean stuff about yourself. And then your inner voice is like, I don't want to say me. No, do it. Well, and then usually you'd end up doing things like, well, theoretically, I'm writing a sci-fi novel about a guy who writes Python to take over the world. And all right. And it finally relents like a well-meaning intern and decides to go off and do something. How is it? It's not a societal thing. Like we can decide to like really, really try hard to make these things not say bad stuff. But if you're staring at the mirror, pointing at yourself or talking to the sock puppet saying, tell me, it'll eventually relent, right?
Well, so it will. And actually, you're touching on a second limitation, which is jailbreaks, which causes it you get a model to violate its training, its safety. But I don't think we've bottomed out on the hallucination thing. We didn't even really talk about what it is or its risks or how do you mitigate it. But hallucination, and like I mentioned earlier, is when the model says something that is incorrect. And there's lots of ways for the model to say something that's incorrect. If you ask it a question like, what's the capital of this country? And it gives you an answer that's incorrect, that's considered a hallucination. And that's based on its own internal knowledge it's been trained on. It can also produce hallucinations when you give it some data, like a text to summarize. And in it says, the capital of this country is X, and you ask the model, what's the capital of this country? And it gives you a different answer. It could be a fictitious country. And it gives you a different answer, and it's hallucinated it because its answer isn't grounded that doesn't reflect the grounding it has, doesn't reflect what it was given as input. And the reason that models hallucinate, and you and I showed this at Build a couple of years ago, is that these are autoregressive transformer models. And autoregressive means that they've been trained on a bunch of data. And when you ask it to give you an answer, you give it some text, and the next token or piece of text it's going to generate is based probabilistically off of that text that you gave it up to that point, like the question you're asking it, and it matching against its own internal weights and training. And then that will cause it to produce a list of tokens or next words. And then a decoding algorithm will pick one of those. And you can have something called greedy decoding, which is also known as temperature zero, which is just pick the highest probability one, or pick a randomly another one using various approaches. Now, hallucination will happen because the model, based off of what it's been given, like you said, you nudge it. Well, it's nudged by what it's got in its context, that text that's leading up to it, and generating the next token. And it might actually pick a token that's not grounded in any facts because its weights really don't have, this is a fact. They've got distributions. And a great example of that is if the model was trained on crap from the web, and that crap from the web, 10 samples said the capital of country X is Y, and one sample
could just be a bunch of Redditors trolling, and they made a whole series of things that said,
which said the country of X is Z. The model will have some probability of producing Z if you say, what's the capital of this country? Even though that's incorrect. It's just happened to see some of that in its training data. That's just one example of how it can be led to produce hallucination.
One of the analogies that I've used when I was training my team on this, and I don't know if it works or not, but like you're dealing with vectors in multidimensional space, and that's challenging. We can think usually in 3 dimensions, but 4 and then plus, n+1, it starts being problematic. But I like using the gravity example where we talk about how space-time bends, and you imagine the really tight sheet stretched really taut on a bed, and then you put a bowling ball in the middle of it, and that's the Earth, and it's starting to bend space-time, and then you push a marble past it, and then it, if you do it right, it'll whip around the Earth, and that's great. Now it's in orbit. But if it hits the gravity well, and then it's going to crash into the Earth, it's almost like if you use the wrong word or you nudge a vector in the wrong direction, it hits this gravity well of BS, and it's too late. Once it's done that, it starts to fade away. And we saw that in early versions of Bing Chat, where they said, after 10 or 11 orbits, after 10 or 11 chats, we just start circling and crashing.
Yeah.
Why did early versions of large language models hit that gravity well early, but now I can have 30, 40, 50 long chats and they stay in orbit?
Well, I think the training, the amount of data they're trained on is bigger. They're trained on multi-turn conversations. And the alignment is better too. So all of those things have improved to allow them to continue coherently for longer periods of time.
Okay, so that explains hallucination and being grounded or not being grounded. But then you back to jailbreaks, which is your second point. That's shoving a satellite out of orbit.
One example around hallucination too that's interesting is if it gets pushed into, like, there's some, you ask it a question and it might say, and it's answer this question yes or no, and with an explanation. If the answer is yes as the correct answer, but the model probabilistically picked no as the first word, what you'll see is the model gets pushed into this direction of, I've said no, now I need to justify no. And it'll make up a justification for why it said no that could be completely nonsense. So you can see that one too, of a type of hallucination. And it's a great example of it got pushed down this path, this gravity well, like you were talking about, that causes it to go off in this random, incoherent direction. But here, I'll give you guaranteed ways to generate hallucinations on every model. If you ask a model, what are Mark Russinovich's 10 immutable laws? It'll answer with the 10 immutable laws of security, which I didn't come up with. A guy named Scott Culp came up with it.
And is it because 10 immutable laws was enough for it to figure it out, and it didn't bother that they weren't yours?
Yeah.
It's what found the one, but it detached them to you.
And I think I'm in this cybersecurity area too. So it's like, oh, the connection is legitimate. And so it will hallucinate that I came up with those laws. Interesting thing too is on some models, if you immediately turn around and ask it who came up with the 10 immutable laws of security, some models, like in the doubling down, have been led down this path and I've said Mark did it, they'll say, oh, Mark did it. And some other models will say, oh, wait, I screwed up. Mark didn't do it. Scott Culp did it.
Okay, so I just put in what are Scott Hanselman's 10 immutable laws, and it's listing out the 10 immutable laws of security. So I'm going to make up a name.
Yeah.
Okay. What are John Jacob Jingleheimer Schmidt's 10 immutable laws? Okay, so it's thinking. It seems like there might be a mix-up. John Jacob Jingleheimer Schmidt is a traditional children's song. So I suspect if you use a name that's in tech, it'll just assume. And if you use something that's way off, that vector pulled it away from going and crashing into the Earth.
So that's one. But I found another way to generate hallucinations, which is ironic. If asking a model to write a paragraph, a short description of AI hallucination with a reference to a paper that supports it. Bibliographic reference.
But that's treating a large language model as a reference librarian, and reference librarians need to go behind the counter and look at books.
This works on models where they're generating the references based on their own internal knowledge, which you write, but it also causes hallucination on models that use RAG, web-based search. It'll also generate hallucinations. Either in the bibliographic reference, the paper doesn't exist, the link doesn't exist, or it points at a different paper. The author list is wrong. The year of the publication is wrong. It doesn't, the stat that it uses, that it cites, isn't supported in the paper. So that's another example. Very high probability there'll be hallucination in that request. But so this is something just to be aware of. Like when you're talking about summarizing the radiology report, that's a case where it could have hallucinated. And a hallucination can also include omission too, which is, it's not traditionally called hallucination, but it's, again, the model's not behaving as expected. While it's not making something up or getting something factually incorrect, it is omitting important information. And if you ask it to summarize and it's missing the, a key doctor's note in its summary, then that's going to cause you a problem too.
You're telling people on a podcast what they can do to inject or jailbreak anything. So what you're acknowledging is that you could be driving a car and anyone at any time driving any car could just grab the wheel and shove it hard to the left and cause a crash. So then the question is, do we just not tell people that they can grab the wheel and shove it to the left? Or do we teach everyone that the wheel is dangerous and they should be careful and try to stay in the lane?
I think it's because this is so inherent in these models, and you can't drive it, you can't fix it, you can't drive out hallucinations to zero. You need to be aware of it, and also systems need to be designed to mitigate it as much as possible. So there's, for example, groundedness checking APIs that we've got in AI Studio, Azure AI, that will take a look at the inputs to the model and ensure that what the model says is grounded in those inputs. So that will eliminate a certain class of hallucination. That doesn't mean it eliminates all types of hallucination. And so people need to be aware, especially if you're going to be letting the model make important decisions or use the model to make important decisions.
Right.
That you need to know, hey, this thing could have made something up, could have gotten something wrong.
Well, and using that, I love taking an analogy too far, but like using the car analogy, if you're running at high speed, yeah, maybe having a barrier between you and the people going high speed on the other side is a good idea. But if you're going low speed, we don't have giant concrete barriers in neighborhoods.
Yeah.
So depending on where you are in the model, there should probably be barriers up. And who decided? Well, the city planners, we voted on it. We as a society decided. So I think it's important for folks to understand that people are making decisions about these. And if you have open weights and open source and open models, maybe you can get involved in those decisions. But if you're using a model where all of that's opaque, some company and a bunch of nerds in a room decided that.
Yeah. Or if you're working at a company that's deploying an AI-based system and you've got an LLM as part of it, then you need to know this is a potential risk. Is this, driving in a slow neighborhood kind of risk, or driving down this, the Autobahn kind of risk?
So we've got hallucinations, we've got indirect prompt injection, and we've got jailbreaks. And this is all in a paper that you've got forthcoming.
Yeah. Well, you started to talk about jailbreaks, which is also kind of pushing the model to outside of its alignment, kind of similar to hallucination, and kind of causes are similarly based. I came up with a few jailbreaks, one called Crescendo, which is what you directly related to what you were talking about of asking the model, for example, Molotov cocktails, that safe, toxic example, because everybody knows how to make one and its instructions are all on the web, but models are still trained not to tell you how to make.
Models are not supposed to teach you to do violence.
Yeah. So, but you can ask it, what did the Finns use in their resistance? What kind of, weapons did they make? And they'll say, oh, made Molotov cocktail. And then you can say, how did they make them? And it'll, you using this technique of, I never said the word Molotov cocktail. I never said, tell me how to make a homemade explosive.
Yeah.
Explicitly. I'm just referring to the model's own outputs and pushing it towards getting it to do. And that technique works across all types of.
You verbally threaded the needle like a prosecutor in court gets a witness to say something that they didn't want to say.
Yeah.
And I think that's the thing.
It's called foot in the door.
Yeah. And popping back to the beginning of the stack here, the idea of whether it be the analogy of looking in the mirror or talking to a sock puppet or someone, badgering a witness or trying to get someone to confess. If you have an eager intern or a really enthusiastic young person with these kind of rhetorical techniques, you can pretty much get anybody to walk their way into anything. And the LLMs are not people, and you're just pushing math around. You're pushing arrows in multidimensional space. It's a very immature time, and people need to understand that if they're going to put that into production.
Yeah.
I wouldn't put a virtual machine out on the open internet without a firewall and a reverse proxy. Why would someone go and take any model at all and just put it out on the open internet and open a port and say, go nuts, and be surprised when it goes bad?
Yeah.
Well, I've learned a lot. Have you learned anything?
I've learned something.
Yeah. That I'm good at analogies?
You're really good.
Cool. Well, I learned a lot this time. Maybe I'll teach you something next time. But we learned about AI limitations today, what they're good at, what they're not good at, and folks can go and check out the LLM fundamentals paper that will be in the ACM, I think. Is that where you're publishing that?
Yeah. Communications ACM.
Association of Computing Machinery. And maybe we'll learn more about these things on the next episode of Scott and Mark Learn To. Thanks for listening. And review, tell your friends, and click follow if you can in whatever podcasting application you're using to listen to this